Thank you so much, Gia, for the warm introduction. And again, thank you so much also for the opportunity to update everyone on the Brainstorm project and software. Thank you, Dr. Jiang, for also the warm welcome. And thank you, everyone, for attending today. We are truly looking forward to great interactions. And so the way it's going to work is indeed, I will start with a brief introduction with a few slides just to present and introduce the Brainstorm short history or not so short history and what it is today and who is contributing, etc. So to give you an idea of the flavor of the project so far. And then Martin will take over for the rest of the session, driving essentially a show and tell live demonstration. But this is also the opportunity to make it, interactive. So I will keep an eye on the chat, indeed. And I told Martin that I will be very rude and interrupting him often, depending on how many questions you folks ask. Or you can also maybe probably unmute if this is more convenient. So let's make it interactive. And I think we have prepared a demonstration that is a bit short of the 1 hour and 30 minutes, so that we can have a real discussion around the tools and maybe also orient some of the demos depending on what this crowd is expecting, okay? So without further ado, I would like to share a few slides with you. And indeed, I'll make sure they are available from the website. So hang on a second. I'm going to just start here. Okay, that's right there. Okay. Okay, can you see my slides just fine?
Yeah, it's great.
Okay, thank you. All right, so what is a brainstorm exactly? So first of all, I would like to frame the discussion under the thesis on the notion that good software can really help implement good scientific practices. We are in a field where data is eventually digital, so we are lucky to have great sophisticated methods that are available to us, data repositories which are also digital. So these are great opportunities to do science efficiently, but we also need to bear in mind that tools are just tools, right? It depends on how we use them. So it's important to understand what the tools are doing, especially if you don't have a strong, let's say, biomedical engineering background or electrical engineering background. That's totally okay. We actually need a strong neuroscientists, obviously, to drive fundamental questions and use these tools to make them useful, literally. So in terms of good scientific practices, as you probably know, there have been a number of important papers, I think, which actually highlight what the community thinks or believes are good practices in the context of EEG and MEG research. I think the crowd today is essentially, or is very attracted by the neuroengineering aspects of, let's say, brain sciences in general. So I'm sure I'm preaching to the core that the methods indeed need to be not only sophisticated, maybe, but I think the sophistication needs to be in the questions, the neuroscience questions or the application questions or objectives, and then the methods will be inspired by those questions, not vice versa. So I will not talk about open science today. This is a broader discussion, but I'm sharing these slides today, and those here, the Open Science, Better Science talk I gave a couple of years ago, that broadens a little bit the discussion around open source, open code, and why this may contribute to better ways of doing science. So please go to SlideShare and just look for my name, under my name, and you will find a couple of slide decks. So yes, my thesis is that good software is likely to enable good scientific practices. So we first need to define what we understand by good software. What is good, right? So let's see a few features, a few items that I believe are important and that should drive the development and distribution of scientific software in our field. So first of all, the tools need to be relevant, like I just said. They need to help address and respond to significant scientific questions or engineering imperatives. The software needs to be easy to learn and easy to use. Otherwise, the learning curve is too long. And, grad students, masters, PhDs, interns, they don't have much time. They want to be productive. They have to. So they need to be proficient quickly while learning a great deal of new notions and concepts, but also tools and methods. So the software has to help. And what is helping a lot is the support that is provided. You can have a great software, but if it's not supported, whenever there is a bug to report or suggestions, for or guidance that you request, it's basically useless. It has to be to some extent foolproof, meaning that it's a tool that needs to be smart enough to let you know when it thinks that you are not using it properly, or you are at the edge of maybe being exposed to, let's say, edge effects, literally, in filtering, etc. That's just an example. It's important in the current academic ecosystem that it is evolutive. I mean, even Word and PowerPoint and Keynote, they have new versions virtually every year. And that's for a good reason. It's not only marketing reasons, it's also because technology is evolving, the needs from users are evolving. So it's important that even academic software be evolutive as well and be open to outside contributions. It has to interoperate with other existing toolkits out there because I think diversity is important in research at every level, including at the level of the tools that researchers and students are using. And maybe Brainstorm, for instance, is great for a few things, but some of you may be very comfortable using EEG Lab for other things, field trip, etc. And you should be actually encouraged to do so, and therefore the software should be working together. You need to be able to share the outcome of your analysis. So not only the figures that you put in the papers, but eventually package your data or your study so that you put it in a Dataverse repository or equivalent, Dropbox, whatever. And then you can publish the data and maybe even the version of Brainstorm and the pipelines that you have designed along with the paper. And this, of course, that's part of the good practices, right? Of reproducible, replicable research. And of course, if the software were free of charge, that would be very nice. But eventually, as everybody has guessed, someone has to pay. So I'll touch upon this later. So, of course, today we're talking about Brainstorm, but many of the software or packages in our field, we're quite lucky, I think, respond to all, if not a few, a few or if not all of these features or items concerning good software I've been talking about. So in a nutshell, Brainstorm is a free open app for multimodal electrophysiology. What I mean by that is that you can do EEG, scalp EEG, depth EEG, cortical grids. We have a new extension that has been published last year for multi-unit electrophysiology. For those of you who do human single-cell recordings, it's pretty rare, but it's happening. But more conventionally, animal models, in vivo, in vitro preparations, etc. We have a great deal of MRI-centric tools, not only for registration of anatomy with electrophysiology, but also for defining regions of interest, computing realistic head models, etc. And thanks to contributions from a group, the group of Dr. Grova here in Montreal, we have an extension for near-infrared spectroscopy. So as you will see with Martin in greater depth, Brainstorm is heavily, or nicely, I should say, interactive. And that's definitely the salient feature with respect to, I'm going to call this the competition, or our good friends and colleagues who develop other packages. We have put since the very beginning of the story, the Brainstorm history, a lot of efforts in making it accessible even to non-coders, non-developers. So there is the possibility to code and develop scripts. I will show you later, and Martin as well, if we have time. But you can start and learn by actually exploring, but also the tools, exploring the features, maybe exploring your data as well, but also, taking the time to basically build pipelines that eventually you will apply using scripts on a large amount of data, for instance. So it's true in the interactions with the tools. It's true in terms of interactions with the data, be it time series, obviously, multidimensional time series, anatomy, in surface, and volume. As some of you know already in the crowd, we have delivered. I mean, we put a lot of energy and enthusiasm, I have to say, in delivering, hands-on workshops and educational course. So, as you know, this event today was expected to be over maybe 1 or 2 days in person in Kentucky. To actually have the users like you bring their own laptops and basically run the demonstration and manipulate or use the software in real time with us. And in our opinion, it's the best way to use practically the software, so that you go back home and you already have a working version of Brainstorm. And often we close these sessions by having users bring their own data, so that again, they go back home and they have at least a prototype of their analysis drafted with us during the session. So this slide is not up to date. We delivered it was a fantastic trip to Dr. Lucero's lab in Talca in Chile. That was in December, maybe already almost a couple of years ago. So I apologize, I didn't, this slide is not up to date. There should be a mini brain here showing where we delivered these workshops. But overall, we provided 40 training sessions to more than 2,000 attendees over the past 9 to 10 years. So this is the curve showing the number of registered accounts, people downloading the software for the first time, and we are approaching 28,000. To me, as a scientist, like many of you, it's a fantastic token of the impact of the work we've been putting in sharing the tools and sharing Brainstorm. And it's fantastic also to see that not only people are using it, but are being productive and successful with the methods, because we are now above 1,600 journal articles, peer-reviewed journal articles, which have used Brainstorm since about 10 years ago, over the past 10 years. So of course, this is thanks to a great team of collaborators, co-investigators, people like Martin, who are true experts and professionals of software development. And this has been really transformative when we were able to hire software developers like Martin, François Tadel on the project, because it brought it from a really poorly coded, very buggy prototype in the early days to something that is now that we can be proud of and more solid and very evolutive. So thank you to them. And thank you also to the support from different funders like the NIH and others who've been supporting this project. And thank you all for being here today again. So let's quickly review some of the features that define a good software, and let's see how Brainstorm fits those imperatives, respond to these imperatives. So relevant tools, as probably many of you know already, there are so many dimensions to the data analysis of EEG, MEG, electrophysiology data in general. This is from a review paper I wrote a couple of years ago, and I tried to capture basically the food chain of the different steps and different levels of data analytics in electrophysiology, from, of course, data collection, review, quality control, artifact correction. We'll see some of that today. Modeling basically the tissues, the head tissues and the generators, and then combining everything for signal extraction and signal analysis in the temporal or in the frequency domain or cross-frequency domain. And of course, statistical tools to derive, to run inferences or classification, machine learning alternatives for exploratory or data-driven options. So I think that we cover pretty much, if not all of these boxes in Brainstorm at different degrees of sophistication. So it has to be easy to learn. Remember, a good software, I think. So this is a snapshot from the webpage of Brainstorm. We feature a 1 hour long video here that is available in YouTube that pretty much covers, you know, the conventional way of analyzing data. And then the rest of the documentation tells you basically what is available, the different chapters. Remember those boxes from the previous slide. Basically, we open each box and we provide tutorials, as it is shown here now, that basically respond to these expectations or the needs of you as users. Like here, I'm showing the different chapters of the tutorials. There are 28, let's say, fundamental chapters, and the rest of the page shows advanced tutorials, probably 40 of them, from epilepsy to depth recordings, to EEG specifics, phase amplitude coupling, statistics, you name it. So again, a big thank you to all contributors, because it's a wiki, so you can also contribute as users to these docs. So this is another example. This is a rabbit hole of the doc. You just go there and we're looking at different ways of visualizing, and you see it's very also interactive with a lot of screenshots, keyboard shortcuts for those when you become more proficient in the software, so you can be more productive with a lot of shortcuts like many advanced software out there. So documentation. It has to be easy to use, and very early on, like I said before, in the design of Brainstorm, we wanted it to be graphically interactive with the user. So we go through a lot of GUIs, graphical user interfaces. Like here, I'm showing, you know, how you can load rapidly MRIs, surfaces from FreeSurfer or other software, visualization of these surfaces, changing, you know, things like colors, transparency, curvature, or smoothing, if you will, of the surfaces, adding atlases of deep structures if you are interested in subcortical circuits and cerebellum. So this can be from the individual MRI, or this could be also from templates, and we feature many different templates that is available to you. And I know that in the EEG community, this is something that is actually very appreciated, because you don't always have access to the individual MRI. This is an example now of interactive visualization of time series. So this is your plain event-related potential, and I think this is from the data Martin will show later today. Visual potentials in EEG. You can display, as you can see, different dimensions in your data, time, space, sensors, for instance. You can apply tools, signal processing tools on the fly, like here, low pass filtering, and it will update directly your data. You can look at the sources, of course, in 3D, and all the windows are linked in time, meaning that if I change the time, in one window, it will update all the other windows. You can define regions of interest that we call scouts in Brainstorm, and you can extract virtual electrode recordings, as we like to say. Here, for instance, the green, I don't know if it's visible on your end, but it shows basically the time series around this right visual occipital cortex. You can also go back to the native volume of the MRI, projecting from the surface back into the volume so that you can run voxel-wide statistics, voxel-wise statistics, or you can register, I don't know, fMRI maps to the MEG source activity. And you see that every time we change the cursor position, it updates the maps on the other end, in the other windows, I should say. Okay, so easy to use. So it has to provide support. And again, thanks to Martin, François, and others, many others in the community, I think we provide a reasonable amount of support through also the user forum. So we don't have an email list. We use this web-based forum, and it's very, very active. I will show you the statistics in a moment, but this is one example where you can put code snippets, images, and this is from Christian Aurélie, who just contributed to Brainstorm distribution. As you can see, an atlas for infant anatomy from 2 weeks old to 24 months old, and we have after that, older children's available. But this is another, fantastic contribution from Christian, who's not from the Brainstorm project per se, but is originally from Lausanne EPFL and is now back in Montreal. So this is the usage, of the user forum over the past few years. Excuse me. I wanted to show you this. Well, here you go. And so you can see that it's growing exponentially, and the trough here is very dramatic. I like to point this out. It's the trough corresponding to the COVID lockdown pretty much throughout the world. And I hope everyone is safe, by the way, and their families and friends as well in the room today. So this is the major impact that COVID has had also on Brainstorm and in general in science, as you probably have experienced yourself. Anyways, so very active support. We need to provide also foolproof, if you will, or guards, safeguards to the users. So we do provide, feedback concerning quality control of the data. So with eye movements, checking power lines patterns and versus actual brain responses. Whenever we can, we provide warnings, we provide error messages that are informative. Whenever you design a filter, for instance, there are parameters to select, and you can look at, for instance, the filter's response in the spectral and the temporal domain so that you can control the edge effects. That's just an example. If you run inferential statistics, parametric stats, you want to make sure your data is approaching a normal distribution. And this is one tool that compares the normal distribution or empirical histograms of your data, any kind of data, to a normal distribution to assert whether you can reasonably run a parametric test. Yeah. We provide more and more tools for simulating data, and I'm thinking of the educational virtue or the, if you will, service that software like Brainstorm can deliver. So whenever you want to understand the effects of certain time series or parameters in your methods, you can run synthetic simulation or synthetic signals, produce those signals, and so that you have a ground truth to look at and compare with whatever is produced by Brainstorm. So the software has to be evolutive, and for this we are using GitHub, like many software projects. And this has been a game changer, like for many of us in the business, of welcoming contributions, keeping track of bugs, and providing a solid framework for new developments and forks along the way. So you're welcome to join the GitHub community with Brainstorm. We want Brainstorm to be interoperable with a galaxy of different tools. So for anatomy, FreeSurfer, BrainVisa, and BrainSuite, among others. SPM, EEG Lab, Filtrate for electrophysiology, MNE, Python. CAT is actually for computational anatomy, and it works with SPM, but you can segment the white, gray CSF scalp portions of the MRI volume directly into Brainstorm using CAT. DuNeuro is a collaboration with great friends in Münster, Karsten Wolters and others, for finite element modeling of head models, of head tissues and geometry. And we also have boundary element modeling through OpenMEG. But the FEM is definitely a plus if you guys do more EEG than MEG. So it's available now. It's a new development from 2020. So not everything is bad with 2020, I guess. We keep an eye on, on standardization of data. So we operate with this project called Neurodata Without Borders, which is an attempt to provide a standardized data format for not only electrophysiology, but many other things. Same idea with BIDS, the brain imaging data structure that has been extended to electrophysiology quite recently. And Brainstorm supports BIDs in that respect. So you can import BIDs repositories, but also package your own data into BIDs so that it's more shareable, and you can put it somewhere on an open repository, and it's easy for others to use again in their own software that is BIDs compatible. And they recover your metadata, etc. at once. Of course, it's built on MATLAB and Java, so it interoperates intimately with MATLAB and tools from MATLAB. And more, you know, thanks to the growing vitality of the Python community, actually MATLAB is building more and more bridges for interoperating with Python, which actually have very positive repercussions on Brainstorm, because we can easily now, or more easily, interact with Python libraries, which are just huge. And so we feature quite a few tools from MNE-Python, for instance, and many other things, or scikit-learn in Brainstorm. And if you look at in the distribution of Brainstorm in the external folder, there is a great deal of other, you know, smaller tools and plugins. And it could be your own plugin if you wish to contribute a certain type of tool. We can provide support for you to actually derive or plug your contributions into software, into Brainstorm, and make it part of the distribution if you'd like to. I'm almost finished. I would like to feature something I'm very proud of, which is actually moving from graphical user interface to, you know, code and advanced computing by just building, for instance, your own pipeline. So here you can build it graphically, as I'm showing here quickly. We'll see more of that today. But for instance, I have a process that removes the eye blinks, then a filter, and then computing the head model. Here I'm computing the sources. I can actually graphically move the different bricks and building blocks around, change their order. I can save this pipeline for myself, or I can share it directly with another Brainstorm user on the other side of the globe. And it saves it in a MATLAB file that I can share via Dropbox or directly by email, if you will. And the person on the other side will just import and load this pipeline in their Brainstorm instance and actually replicate what I've been doing. You can save your own library of processes, so that the next day or 3 years from now, you can go back and load it back, and you see the process is back here. And you can generate a script. So you can generate basically the code that is behind the GUI, and automatically. And this is what you see here. You see these different calls, you know, iteratively in the script. And these are calls to different library functions of Brainstorm. And you can use this code to insert your own processes. And again, you can execute it in headless mode with no GUI on an advanced computing resource server. And we provide even more sophisticated codes. This is one example here. That is actually a code and a script that reproduces one of these two papers that we published last year with the group, one for group analysis and one for resting state analysis. And this is in a special issue of Frontiers in Neuroscience, so please Google it. And you will have a link at the end of the paper that can let you download the data, download the script, reproduce the analysis, and all the figures that you're going to find in the paper. And at the end of the day, if you are happy with it, you can actually plug your own data in it and see what happens, and or change a few parameters and see how it changes the outcome. So I think it has great value in that respect too. So yes, this comes with a cost. We were fortunate enough to be supported by the NIH and other generous funding agencies, so we can distribute Brainstorm freely, but we realized that MATLAB isn't free, right? But we have to be, let's say, realistic or appreciative of the fact that it's still available to thousands and thousands of students, professors, and trainees in higher education around the world. It's still not free and not available to many, many more. We are very conscious of that, of course. But the thing is that we also provide provide a compiled version of Brainstorm. So even if you don't have access to MATLAB through your institution, you can still use Brainstorm in full on any operating system with a compiled version. So you still have access to the code. You cannot modify it to change how Brainstorm runs. That's the only bottleneck. But at least you have access to the same high quality tools and support and documentation for free. So my takeaway today is actually very simple. I hope I have demonstrated or pushed the envelope towards, the fact that good software, and I'd like to say like Brainstorm, can facilitate your life as a student, as a researcher, as a scientist, as a teacher, and by enabling good scientific practices and taking you to the next level of productivity. So please stay connected. If you are interested, please Google Brainstorm MEG or Brainstorm EEG. It will take you directly to the Brainstorm homepage. We try to be active and have a little fun on Twitter. And so we share the latest news or latest publications that we think are particularly original using Brainstorm. So please follow us on Twitter. Facebook also, even though it's for old folks like me. We are not on TikTok yet or Snapchat, but I'm keeping an eye on my teenagers to see what's the next cool thing. But for now, we are on these platforms. So again, we do that because we are inspired by great users and inspired users like you, sorry. And these are just two examples, recent examples from the literature that were particularly spectacular or very significant to me. So this one is from the Grenoble research group, Clinatech, where they have implanted a quadriplegic patient who could not work or could not move anymore with electrodes in the motor cortex so that he could use, if you will, biofeedback, neurofeedback to let's say drive or walk with an exoskeleton, as you can see here. And they had used the Brainstorm to basically do the pre-surgical mapping for the implantation of the probes so that they had the best chances of success in terms of targeting the motor cortex of that person. So that's really high tech and really brings a lot of hope for patients like this one and others. And I know a lot of you are interested in neurofeedback or neuroengineering, and I think this example is an ultimate example of that field to some extent. And I'm also I was very happy when I saw this study from a group in the US and in the Democratic Republic of Congo, where they were studying the effect of child labor on literacy. So they were scanning using NIRS, these little children who were forced to go out in the fields and taken out of school to work, basically, because of the terrible poverty conditions there. And they were not only testing them behaviorally on their literacy, but also looking at brain signals with FNIRS to correlate with behavior. And they used Brainstorm in that study, and I was so proud and also very impressed by what they had achieved. So I wanted to mention that to you today. So with that, I would like to thank you very much for your attention and your kind interest. And I will pass the podium and the microphone to Martin for the real deal. Thank you so much.